In today's lesson, we're going to be talking about the ambiguous case. Let's consider now the ambiguous case. If I have an angle and two sides that do not sandwich the angle, I can draw one triangle here, 30 degrees, 5 centimeters, 2.5 centimeters. Notice that that's an obtuse angle, greater than 90 degrees. Well, the same given information, 30 degrees, 5 centimeters, 2.5, can produce an acute angle. What's going on here is that 2.5 is longer than our height. Here is our height. And so think of this as the center of a circle, and this is a radius. I could swing this radius C, and it would make a circle and meet the line AC right there, and I could make another triangle here. This triangle here is actually this triangle. Well, if this is 2.5 centimeters, if I'm swinging it like a radius, then this is 2.5 centimeters as well, as you saw here. This side is really the same as this side here. Well, we know that isosceles triangles have base angles that are equal. So if this angle is equal to this angle, then this angle here, which I'll draw with two stripes here, which is also this angle here, these two angles are going to be supplementary, or they're going to add up to 180 degrees. The main point here is that the ambiguous case, given this, and this, we can draw two different triangles. So you have to specify which triangle you're talking about. The one with the obtuse angle or the one with the acute angle. Let's do one example with the ambiguous case. For the triangle shown, find the angle ABC. Well, if here is A, and here is B, and here is C, we're looking for that angle there. For that triangle shown, well, that is an obtuse angle. If we do it in our calculator, though, we're going to get an acute angle. So we have to draw the picture. Well, I could also draw this picture out like this. This is also 10 centimeters. Think of this as the center of your circle and tracing this radius like that. And we'll intersect this line AB in two spots. Maybe this is my triangle. I'll call that B prime way out here. Well, how can I solve this? I can use the sine rule. I can say that 20 over sine B is equal to 10 over sine 20 degrees. If you cross multiply and solve for B, we're going to get sine B is equal to 20 sine 20 degrees. And sine B was times 10, divide both sides by 10. We'll divide both sides by 10. We're solving for sine B, so we're going to have to take the inverse sine of both of these. So I'll take the inverse sine of this. When I do that, I get 43.1 degrees. Well, clearly that's acute. This is 43.1 degrees. Then this, if I'm looking for the obtuse angle, that will be the supplement of 43.1 degrees. So it will be 180 degrees minus 43.1 degrees. And that will give you your obtuse angle there. When will we see the ambiguous case? Well, on the board here I've drawn 6 different cases of triangles, and only one is the ambiguous case. If I have acute angle alpha here, side A and side B, if A is less than H and A is less than B, I'll never be able to close this triangle, and so I have 0 triangles possible. Again, acute angle alpha, if A is equal to H, I get one triangle, a right angle triangle, 90 degrees there. If this side A is greater than both H and B, then I only get one triangle, an obtuse triangle with an obtuse angle there. Here is where we find the ambiguous case. My angle alpha is an acute angle, and A is less than B. Clearly A is less than B, but it's also greater than my height. So if we think of this as the radius of a circle, it's going to hit here and then hit here as I swing it around. So this is my ambiguous case. I'll get 2 triangles here. If the angle alpha is obtuse greater than 180 degrees and A is less than or equal to B, I will not be able to form a triangle. There's 0 triangles you can make there. And if angle alpha is obtuse, only if A is greater than B will I be able to make one triangle there. So when A is greater than H but less than B, that's when we're going to have our case of the ambiguous triangle.